All right. Hi, everybody. So, bear with me while I try this new method of recording. I have my iPhone rigged up in my office. We're going to try recording this way and see how it goes. All right, so this is a lesson on 5-2, which is solving inequalities. Involving multiplication and division. All right? So before I go on with this, I'm going to do a little review of 5-1, which involved solving inequalities with only addition and subtraction. For a review, since we've been on break and probably gotten a little rusty. And also I want to kind of tie it in with this section. Okay, so review. In section 5-1, we talked about equations like this. X plus 2 equals 7. Well, this is pretty simple. We know to undo addition, we would subtract 2 on both sides, and we would get x equals 5. Okay? The only thing that would be different about this, if the equal sign were an inequality symbol, such as a less than or equal to, a greater than, or a greater than or equal to, is this. We would change the symbol. Okay? The math would work exactly the same. But then our final solution, instead of being just a single number, x equals to 5, this includes a whole huge range of numbers. Okay, so any value that is less than 5 would make this statement true. So the math is the same, but then we show the answer a little bit differently. When it's a less than or greater than only, as opposed to a less than or equal to, or a greater than or equal to, then the circle on our number line is an open circle. So you just put an open circle at 5, and then we shade on the correct side of 5. So this is all numbers, the solutions to this statement are all the numbers that are less than 5, which are numbers like 4, 3, 2, 1, which are of course on this side, so then we would shade this way. But again, the only difference, there is no difference in how you solve this mathematically, it's just how we show the answer, okay? Now, just to review, if this were less than or equal to, the only thing that would change is this would be a closed circle. So that would mean that 5.0 would be included as well, whereas before it would not have been. Okay? So let's do one more. What if this was x minus 2 is greater than 7 or something like that? Okay? So again, the math would be exactly the same as it would be if this were an equal sign. To undo subtraction, we add, have to do the same on both sides, and then we'd have x is greater than 9. The math is exactly the same, we just write the answer a little differently. This is not a single number 9, this is all the numbers that are greater than 9. So we would make a number line, put a circle at 9. It would be open because it's a greater than as opposed to a greater than or equal to. And then we would shade the correct side of this. This is all the numbers that are greater than 9, which are numbers like 10, 11, and 12. They would be on this side, so I would shade this side, okay? And just to get all fancy on you, let's make sure we know the rules, the names of the rules that allow us to do these things, okay? So when this is an equal sign, an equation, the rules that allow us to do this are called the addition properties of equality or the subtraction properties of equalities. And then, of course, if we have our inequality symbol, not very shocking, these rules are called the addition properties of inequality and the addition properties, and the subtraction properties of inequalities, okay? So in 5-1, where we were solving equalities, not multiplication and division, just with addition and subtraction like these, you can see it's really simple, it's exactly like equations, except the way we show the answers is a little bit different. Well, now we need to investigate how things work with multiplication and division inequalities. Okay, so I do want to go through the little exercise that the book goes through on page 292, so please follow along. Okay, we start with 4 is greater than 2. Okay, I think we'll all agree that is true. Okay, so now let's see what happens when we multiply both sides by the same number. So let's have a number like 3. So if I multiply 4 by 3 and I multiply 2 by 3, I get 12 and I get 6. And if I were to just bring the same symbol down, I would have 12 is greater than 6. That is also true. Okay, so the what would you say, the integrity, I guess, the basic way that these two numbers relate to each other is respected. It's maintained when we multiply by a positive number, okay? So far it appears that the rule would work the same way that it does if this were an equal sign. Okay, but now we're going to try this with two different numbers. 7 is less than 9, okay? This is, of course, also true, but this time we're going to multiply by -2 on both sides. So, if we, well, I'll do it the way the book does. Let's see. Give myself a little more space here. So if we multiply by -2, and we multiply by -2, we get -14, we get -18, and if we bring the symbol down like we did before, then we get -14 is less than -18. Now, is that a true relationship? No, it's not. Hopefully you said no, it's not. Remember that positive numbers and negative numbers, the numbers on the negative side of the number line are just a reflection of the numbers on the right side of the number line. So if you think about if 0 is here, and -5 is here, and -10 is here, and -15 is here, and -20 is here, -18 would be about here, and -14 would be about here. And you know, the more leftward we are on the number line, the smaller the number is. So -18 is in fact less than -14. So this relationship is not true, okay? This is not true. So, I want you to think for a moment before I tell you the answer, or you could peek in your book and find out. What do you think might be, jot down what you think, how these situations work. When we multiply by a positive number, the inequality remained true. But then when we multiply by a negative number, like -2, like here, the inequality did not remain true. So I want you to make a guess, an educated guess, and jot down what you think we should do and how this works. And then I'll tell you in a moment. So pause your camera, pause your recording for a moment, jot down how you think this works, and then resume, and we'll check and see what you think. All right, we're back. So 7 is less than 9. When we multiply this side by -2, and we multiply this side by -2, get -14, -18. But for this relationship to remain true, our symbol, which was facing this way originally, right, has to flip the other way. When you flip it, it does make a true statement, okay? So hopefully you were able to kind of make that guess before I even told you. Now we need to write it as a formal rule, okay? With inequalities, okay, and again, the 4 types of inequalities are less than or equal to, greater than, and greater than or equal to. With inequalities, you must flip the inequality symbol when what happens? When you multiply or divide by a negative number, okay? When you multiply or divide by a negative number. All right? bit strange, but you'll get used to it. We're going to do some more examples in just a moment that help you practice this. But the good news is this is the only major difference with inequalities, okay, involving multiplication or division. When you're solving and you have to multiply or divide by a negative number, you must flip the inequality symbol, okay? All the other math works just like it did when this was an equal sign, okay? So let's do a few examples.